Equivalent fractions. In this clip, we're going to examine what an equivalent fraction is and how they can be the same amount, however, look different to each other. So what is an equivalent fraction? They are fractions that are cut up differently, however, they also are exactly the same amount to each other. So we can have two differently named fractions that are cut differently, making them look somewhat different. However, they are the exact same amount when you add up how much you've got. So equivalent fractions are different fraction types and are equal to each other. So let's examine this through an example. So first of all, let's start with a circle and let's cut that in half as shown. So since we've cut it in half, the denominator is 2, or the bottom number. And if we colour in just one of those pieces to make 1/2, that would mean the number on the top, called the numerator, is 1. Now, if we cut it again in half the other way, we can see we've actually cut it into 4 equal pieces. So now we have quarters. And because we've cut all the pieces, we've also cut the red piece into 2 pieces. So in red, we have 2 quarters. So if we look closely here, we can see that we started with a half, we've cut it and made it 2 quarters. So we've got 2 different fractions, 2 different fraction names with different numerators and denominators. However, they are actually the same total amount. So 1/2 is equal to 2 quarters. If you were allowed to eat half of this pizza or 2 quarters of this pizza, depending how many times you cut it, you'd be coming away happy that you got the same amount. So they are exactly equal, they are equivalent to each other, which is why they're called equivalent fractions. Of course, they look different because they've got different amount of cuts, but they are the same amount, which is what makes them equivalent fractions. So I'm just going to move the shape to separate them out here. So I've got a circle that I'm cutting into quarters, so that's the denominator, and here we have 1/4. Now we've got 2 quarters, and we can see, comparing them, we can see that they are indeed equal. The shape on the left in red is the same amount as the shape on the right. However, one is cut up more than the other. So 1/2 and 2 quarters are the same amount, although cut differently, and so they're named differently. They're equivalent. Now I can do the same on the left here. I'll cut the red shape again to be back into quarters. And so now I've got 2 quarters on the left. So 2 quarters on the left is equal to 2 quarters on the right. They're no longer equivalent as such. They're actually the exact same cuts. So it's just 2 quarters is 2 quarters. They're equal. But if I keep cutting on the left, and now I've cut my red shape into 8 pieces, and there's 4 of them that are coloured in red as a result. So now I've found yet another equivalent fraction. 4/8 is the same or equivalent to 2 quarters. Now we can still see that both of these shapes are half coloured in. So half is of course equivalent to 4/8, which is also equivalent to 2 quarters. And I could keep cutting and cutting and cutting forever. And I could come up with countless, endless equivalent fractions for 1/2. And the way that I write them down below and the order I write them is not important. So I can shuffle those around because they're all equal to each other. And we can have other options as well, such as 5/10 or 3/6. All of these are possibilities that could be equivalent to 1/2. Let's just explore 1/2 just a touch further by looking at this shape above that I've put to the middle. Here, 1/2 is coloured in green, so we'd call it 1/2. If I cut it, as we've seen before, that would be 2 quarters, which is equivalent to 1/2. Cut it again, I've got 4/8. So far, so good. We've seen all of this. That's equivalent to 1/2. But I could keep cutting. If I cut it everything into half yet again, every piece gets halved. The number of pieces I've got doubles. So now I've got 16 pieces, so it's 16ths. And I've got 8/16ths there. And we can see a pattern of how a half has a numerator and denominator, with the numerator being half as big as the denominator. And this is limitless, of course. I could just come up with any combinations I wish. And of course, if I went to 50ths, so now I've cut 50 slices here, we would then assume that coloured in green there would be half of those 50. So that would be 25 50ths. So I think we've got the idea of the basics by now of what an equivalent fraction is. So let's move on just to another example, just to strengthen our understanding. And this time I've got a triangle shape because fractions can come in any form, and it's cut into 3 pieces. So these would be thirds. So I've got one piece coloured in, so that would be one of them as the numerator, one piece that I have. And as I've already said, they are thirds, so a 3 becomes the denominator. Now I can cut this shape further. So I've cut into 6 equal pieces. By doing that, it means my one piece gets cut also into 2 pieces. So I've got 6 pieces total, making sixths, and I've got 2 now as my fractions shown in the picture. So of course, 1/3 is what I started with. So it's still 1/3, but now it's cut into 2/6, and they are equal to each other. So they are equivalent, and that makes them equivalent fractions. I can move these out to be beside each other. So now I can see the original shape that I had before I cut it, which is 1/3 on the left in orange, and I've now used red to show my 2/6. These two shapes, we can tell, are equal to each other. They don't look exactly the same because they're cut differently, but the amount coloured in orange or red are equal. So they are equivalent to each other, and we can name them as 1/3 and 2/6, and confidently say that these are equal and equivalent to each other. Okay, let's change this up now. So I've gotten rid of my numerator of 1 for 1/3 because I've decided to colour in an extra third. So now I've got 2/3 on the left, and I've got 2/6 on the right. So clearly, I cannot say that they're equal to each other. So I can use this symbol, which is an equal sign with a cross through it, which means they're not equal. These are not equivalent fractions. Clearly, the 2/3 in orange is larger than the small sixths, which are 2/6 on the right. In fact, 2/3 is larger. I can use my greater than symbol. 2/3 is greater than 2/6. But it's more accurate to use this symbol, which means they are not equal to each other, because that is telling me they are not equivalent or not equivalent fractions. To make them equivalent, I would need to not have 2/6 on the right. I need more of them so that I can have as much as the orange 2/3. So I would start colouring them in. And once I did that, I can find that 4/6 will get me the same amount as 2/3. And so now I have those shapes being equal to each other and equivalent. So 2/3 is equivalent to 4/6. Okay, let's move on to another example. This time we're going to use 2 bars or 2 rectangles, and I've put them vertically just to show you that it doesn't matter which direction we do our rectangles. And I've cut them both into 5 pieces each, which would make them both fifths. So on the left and the right, they're exactly the same at the moment. The shape on the right, I'm going to cut into smaller pieces. And now they're in 10 pieces, so now they're tenths. They're still the same amounts on each side. However, one's now fifths and one now is tenths. I'm now going to colour in 2/5 on the left. And if I want an equivalent fraction as tenths, I would have to colour in the same amount of the bar, which would make more pieces coloured in because they're smaller, and 4/10 would be equivalent. So now equal to each other, and 2/5 is equal to or equivalent to 4/10. I can now change it up and decide to colour in more of each shape. And as long as I'm colouring in the same amount of each side, they will remain equivalent. So now I have 2 equivalent fractions shown above, and I just need to count how many pieces I have for the numerators to know what the fractions are. And so of course I've got 3 pieces on the left, so 3/5, and I now have 6 pieces on the right, so 6/10. So 3/5 is equivalent or equal to 6/10. Okay, so I can now keep going and keep cutting. So now I've decided to cut the shape on the right, the 6/10. So they're no longer 6/10. They're now cut up into 20 pieces, so they're called 20ths. And I now have 12 of those small 20ths. So it's now 12 20ths that I've made on the right here. The shapes are still equal to each other if you compare how much purple is coloured in. So 12 20ths is equivalent to the 3/5 on the left, but also equivalent to the 6/10 as it looked before I put that cut down the middle. So all these three fractions are equivalent to each other. Now I can cut the 3/5 on the left. Now I'm going to do something different here just to be deliberate in showing you that we don't always have to be cutting things in half. I'm going to cut this into threes, or cut it by thirds. So I'm going to put 2 lines down the centre as so. Now I have to make sure that these lines are evenly spaced, that I'm making sure that each fraction part is identical in size to remain a true fraction, and I can do that as long as I measure properly. And as a result, now I have 15 equal pieces. So they're 15ths. And if I count up how many are coloured in purple, there are 9, so it's 9/15ths. And of course, 9/15ths is an equivalent fraction to the 12 20ths on the other side, but also equivalent to the 3/5 and the 6/10 that we started with. So along the bottom, I've listed all 4 fractions that we've explored using these shapes with the purple coloured in, and all of them are equivalent to each other.